Hello, and welcome to discover together the Gaut output files. We'll discover first the ones that are in the debug directory. Remember, it is the dot files, the SVG files, the pseudocode, and the other intermediate files. So first, let's open the dot files. Let's see first the CDFG, which is the translation of the input specification in the C code. And it is the control data flow graph, which contains the CFG, the control flow graph, with all the basic blocks, and also the data flow graph, the DFGs of the basic blocks contained in computations. For example, here the basic block 88 is detailed. So we can see the first operation node, multiplier, which multiplies x by x. Then the results is multiplied here by 3, which is the constant a. In parallel, we have the multiplication of x by b, which is translated as a left shifts by 1, which is equivalent to a multiplication by 2. And then we have the first addition and the last addition with the C constants. And it returns the results. So now if we double click on the data path dots and the FSM dots, we obtain the two other graphs. This one is the final state machine. It is here a linear final state machine because there is no loops in our example. And in each state, you have the detail of the operations that are executed in these states. And the last one is for the data path. We can go further and see the scheduling trace, which is the SVG folder. So double click to open the SVG file. And inside we have the detail of the scheduling and the binding of the operations, cycle by cycle. So we have in cycle 0 the first multiplication and the L shifts, then the second multiplication using the same multiplier, and in the last two cycles the two additions. The pseudocode is generated is a TXT file that you can open in the editor, and you can see the detail of affectations in each basic block. So this is very helpful when you need to debug your architecture. Then let's go and see the CDFG file generated by Gaut. So inside you have all the declarations of variables and constants and the functions. So this is the image of the output of GCC. Then we have the second step, which is the Gaut model. So again, we'll find inside the detail of the declarations and also the composition of the functions. Then we have the RTL model, which is the .rtl file. And here you have all the declarations and all the structures needed to generate the RTL description, for instance, for VHDL. So we have the package declaration with the components and all the signal declarations as well. And in the last, we will see the .gstates, which is the statistic of the resource usage of our architecture. So for each function, we have the number of operators that were used, multiplexers, registers, and the number of states of the final state machine. So if you click on the operators and then move to the property view, you can see that we have 3 instances of operator which are used. And if you expand, you have the detail for each operator type. Here the number of registers with the data format as well. So we have 2 instances, 2 registers, 32 bits. And the final state machine contains 7 states that we can see here. 1, 2, 3, 4, 5, 6, 7. Okay, so that's it. These are all the outputs that are included in the C++ project. Thank you for listening.